Okay, Miss Millender here one more time. And again, I'm going to ask you to open your composition books, fill in the table of contents with your assignment number, page number, date, and calculations showing your work is the title of the notes. So to take care of that, you might want to pause and I'll wait for you to come back. All right. So if you want full credit on any calculation, and I'm assuming you do, but maybe not, but if you do, you have to follow these instructions. All right, so it's pretty straightforward stuff. You just, if you don't want to lose points, then you have to do it this way, right? You have to show your work. Oh, but I could do it in my head. Oh, yeah, well, I can't read your mind, so you've got to show your work. Okay, even if it's a simple adding things, you still have to show work. The first thing you need to do is show the original formula. So, for example, the density formula is mass divided by volume. So you would show that. Now, sometimes there's a little twist to it. In other words, in this example, we're solving for D, which is density. So I need to find or measure a mass and a volume, and then I can do the calculations. However, we can use this formula and still solve for M or V. We don't have to solve for D. So what you need to do is show the formula so that it's manipulated, so that the unknown is alone on one side of the equation. I always put the unknown on the left, but I don't know. I just think it's a good idea. So here we go. This, instead of looking for density, I'm looking for mass. And mass is density times volume. And there it is. So that's what I would show. I don't have to show the D equals M over V because that's not what I'm using. I'm using the M equals D times V. And we'll go over how to manipulate equations in class. It's in your handbook, which you don't have yet, but we'll get it. So we'll deal with that at a different time. Another thing is, if there is not a standard formula for the calculation, you have to make one up. So if you are looking for density or velocity or pressure or volume or whatever, there's always a formula made up already that you can use. However, this is one of the more common ones that you're going to have to make up, which is an average formula. So if I had a whole bunch of densities for something, I would want to find the density average. So I would take, let's say, the 5 densities, add them together and divide by 5. The whole point of doing this is so that the reader of your lab or your work knows what you're doing. You can't just say, oh, my teacher knows what I'm doing. No, you have to put it down there. It's all about communication. All right? So that's the first part. Number 1, show the original formula, whether it's in its original form or manipulated. And if there isn't one, you need to make one up. My dog is whining. So we're going to continue on this. With number 2 is you have to substitute numbers with units in for the variables. So this is pretty straightforward. If this is the formula we're using, and I've measured or I've calculated the density or looked it up, then I could say the mass is equal to 3.228 grams per milliliter, that's the density, times the volume of 9.4 milliliters. So the first thing you do is show the formula. The second thing you do is substitute the numbers in for the variables. All right. The third thing you have to do is show your answer with the proper units and sig figs. Now, units we're going to talk about right now. Sig figs we're going to kind of put off for a couple of months, and we're going to come back with that, but I didn't want to give you the notes without the sig figs in it. So you can ignore that term, sig figs, for now. We'll just deal with units. So when I calculated it out, it came to 30.832, and I rounded it to 31 grams. So that's my mass. So there it is. That's what you have to do to get full credit. So let's look at one example all done at the same time. All right? Here we go. So let's say we'll go back to that density formula because you're actually going to be doing this soon. So we might as well use this. So I measure a whole bunch of plastic rods, and they all have the similar but not exact densities, and I want to get an average. So I've set up this formula because there is no defined formula for density because it depends on how many measurements you have. Okay, so then I have to plug my numbers in. So here are in substituting in for D1, 2, 3, 4, and 5, I've put in the measurements that I actually got, or the numbers that I looked up. Notice that every single one of those measurements has the unit centimeters on it. Yes, you have to do that. That's, if you want full credit, you've got to do it. There it is. And then you do your calculation and you get 4.758 centimeters, which will round to 4.76. So it's pretty straightforward, and that's what you have to do when you're doing calculations if you want to get full credit. And as usual, if you have any questions, please write them in your notebook and bring them to class so they can get answered. All right, thanks again.